Somewhere out there, beyond the familiar twinkle of our night sky, past the swirling nebulae and distant galaxies, lies a reality that defies our terrestrial comprehension. The universe, for all its beauty, harbors secrets that can chill you to the core. It's a realm of unimaginable power, where gravity reigns supreme, and the very fabric of space-time is stretched and torn. We're not talking about the gentle vacuum of space, or the frigid temperatures that permeate the cosmos. No, this is a different breed of danger entirely. We're talking about places where the laws of physics as we know them begin to falter, where matter is pushed to its breaking point. Join me now, fellow travelers, as we venture into the abyss. Let us embark on a journey to explore the deadliest places in the universe. Space itself is a harsh mistress. Here on Earth we're blessed with a life-sustaining atmosphere, a magnetic field that shields us from harmful radiation, and a gravitational pull that keeps us grounded. But venture beyond our protective bubble, and you enter a realm of extremes. Temperatures fluctuate wildly, plunging to near absolute zero in the shadows of stars. Air, that precious elixir of life, is non-existent. And gravity, it becomes a force of unimaginable power. But even amidst these dangers there are pockets of the universe where the stakes are infinitely higher, where the very fabric of existence is threatened by forces beyond our comprehension. These are the places we're here to investigate, the cosmic monsters lurking in the darkness, neutron stars, remnants of stellar explosions, where matter is compressed to unimaginable densities. Quasars, blazing beacons fueled by supermassive black holes, spewing out jets of deadly radiation, and the enigmatic gamma-ray bursts, the most powerful explosions in the universe. We're not talking about the slow, agonizing demise of suffocation in the vacuum of space, or the creeping chill of cosmic frostbite. No, these are threats of an entirely different magnitude. Imagine, if you will, being instantly vaporized by a blast of radiation so intense it could sterilize entire star systems, or being stretched and compressed like cosmic chewing gum by the unyielding grip of a black hole. These aren't just abstract concepts, mind you, these are very real dangers lurking in the depths of space. Places where the laws of physics themselves seem to break down. But fear not, intrepid explorers, for knowledge is our shield and understanding our weapon. By unraveling the mysteries of these cosmic death traps, we gain a deeper appreciation for the delicate balance that makes life on Earth possible. Today, we'll journey to these cosmic abysses, peeling back the layers of mystery to reveal the science behind these extraordinary phenomena. We'll explore the remnants of dead stars where gravity is so intense that a single teaspoon of matter weighs more than Mount Everest. We'll venture perilously close to supermassive black holes where time itself bends to the will of gravity and even light cannot escape its clutches. And we'll brace ourselves for the raw power of gamma-ray bursts, those fleeting yet cataclysmic events that can outshine entire galaxies for a few terrifying moments. Fasten your seatbelts, my friends, because this is a journey unlike any other. This is a trip to the edge of existence, to the deadliest corners of the universe. Our first stop takes us to the remnants of a once mighty star, a neutron star. These stellar ghosts are born from the death throes of stars far more massive than our own sun. Imagine a star, much like our own, but hundreds of times larger. For millions of years it burns brightly, fusing hydrogen into helium in its core. But eventually its fuel begins to dwindle, and the outward pressure of nuclear fusion can no longer hold back the relentless inward crush of gravity. The core collapses in on itself, a catastrophic implosion that triggers a supernova, one of the most violent events in the cosmos. The star explodes outward, spewing its guts across the galaxy. But from the ashes of this cosmic cataclysm, a new entity emerges. The core of the star, once the size of a city, has been compressed into a sphere no larger than Manhattan. This, my friends, is a neutron star. Now imagine taking all the matter in our sun, a star 333,000 times the mass of Earth, and squeezing it into a ball just a dozen miles across. That's the density of a neutron star. A single teaspoon of this material would weigh billions of tons here on Earth. That's heavier than Mount Everest. In fact, the gravitational pull on a neutron star is so strong that if you were to drop a marshmallow from a height of just 3 feet, it would hit the surface with the force of an atomic bomb. But the extreme density of a neutron star is just the beginning of its deadly repertoire. You see, as the core of the star collapses, it also spins faster and faster, like a figure skater pulling their arms in during a spin. Some neutron stars, known as pulsars, spin hundreds of times per second, emitting powerful beams of radiation that sweep across the cosmos like cosmic lighthouses. These beams are so intense that they can be detected across vast distances, making pulsars some of the most useful tools in astronomy. But don't let their beauty fool you. Get too close to a neutron star, and you'll experience the full fury of its deadly embrace. The gravity alone would be enough to rip you apart, stretching your body into a long, thin strand of atoms, a process scientists affectionately call spaghettification. But before you can say supernova, you'd be bombarded by intense radiation, fried by lethal doses of X-rays and gamma rays. And if you were unfortunate enough to encounter a magnetar, a type of neutron star with a magnetic field a quadrillion times stronger than Earth's, well, let's just say it wouldn't be pretty. The magnetic fields of these stellar monsters are so powerful that they can distort the very fabric of space-time. So, while neutron stars may be small, they are undoubtedly some of the most extreme and dangerous objects in the universe. We've explored the incredible density of neutron stars, but now, let's turn our attention to something even more monstrous: quasars. Imagine a black hole, a cosmic abyss from which nothing, not even light, can escape. Now picture that black hole indulging in a cosmic feast, devouring unimaginable amounts of matter, gas, dust, even entire stars. This, my friends, is a quasar. It's essentially a supermassive black hole at the heart of a galaxy, a gluttonous behemoth with an insatiable appetite. As matter spirals into the black hole's gravitational grip, it forms an accretion disk, a swirling vortex of superheated material. The temperatures in this accretion disk are staggering, reaching millions of degrees. This heat generates a blinding light, sometimes outshining the combined light of every star in the host galaxy. Imagine the luminosity of 1 trillion suns concentrated into a region the size of our solar system. That's the raw power of a quasar. And it's not just light. Quasars unleash torrents of energy across the electromagnetic spectrum, from radio waves to X-rays, and even powerful jets of plasma that travel at nearly the speed of light. These jets, stretching for millions of light-years, are a testament to the incredible forces at play. Quasars are the most luminous objects in the known universe, visible across vast cosmic distances. In fact, the light we see from them has journeyed for billions of years, offering us a glimpse into the early universe. They are beacons from a time when the universe was young and galaxies were still forming. The discovery of quasars in the 1960s revolutionized our understanding of galaxies and the evolution of the universe. It showed us that these incredibly energetic events, powered by supermassive black holes, were not merely theoretical constructs but actual phenomena shaping the cosmos. But their very existence raises profound questions. How do black holes, regions of space-time where gravity is so strong that nothing can escape, power such luminous objects? The answer lies in the incredible efficiency of energy conversion around a black hole. As matter falls into the black hole, it is essentially converted into energy, released in the form of light and heat. This process, governed by Einstein's famous equation E equals mc squared, is far more efficient than even the nuclear fusion that powers stars. Now you might be wondering what would happen if our solar system had the misfortune of being in the path of one of those powerful quasar jets. Well, let's just say it wouldn't be pretty. The sheer energy of the jet would be catastrophic. It would strip away our atmosphere, boil our oceans, and melt the very surface of the Earth. Life, as we know it, would be extinguished in an instant. Thankfully, we're nowhere near a quasar. The closest one is billions of light-years away. But their existence serves as a stark reminder of the immense power that lurks in the hearts of galaxies, a power that can both create and destroy on a colossal scale. So the next time you gaze up at the night sky, Remember the quasars, those distant, brilliant beacons? They are a testament to the universe's capacity for both awe-inspiring beauty and terrifying destruction. From the blazing fury of quasars we journey now to the ultimate abyss, a place where gravity reigns supreme, where space and time themselves are warped beyond recognition. We are talking, of course, about black holes. Imagine a region of space where matter has been compressed so tightly that its gravity becomes inescapable. Not even light, the fastest thing in the universe, can escape its clutches. This point of no return is known as the event horizon, a boundary in space-time beyond which our current laws of physics break down. Cross the event horizon, and you're on a one-way trip to oblivion. There's no turning back, no sending messages back to the outside world. You would be cut off from everything you know, forever trapped within the black hole's gravitational grasp. But what exactly happens inside a black hole? That's a question that has puzzled physicists for decades. Some theories suggest that you would be crushed into oblivion at the singularity, the point of infinite density at the black hole's core. But the journey towards this singularity wouldn't be pleasant. As you approach the black hole, the gravitational pull on your feet would be significantly stronger than the pull on your head. This difference in gravitational force, known as tidal forces, would stretch you out like spaghetti, a process aptly named Spaghettification. And if that wasn't bad enough, time itself would start to behave strangely. Near a black hole, time slows down relative to observers farther away. This phenomenon, known as time dilation, is one of the most mind-bending predictions of Einstein's theory of general relativity. Imagine someone watching you fall into a black hole from a safe distance. As you approach the event horizon, they would see your movements slow down, your image redshifting until you eventually fade from view. To them, it would appear as if you were frozen in time at the edge of the abyss. But from your perspective, time would continue to flow normally. You would witness the universe around you distort and warp as you continued your inexorable journey towards the singularity. Black holes come in various sizes, from stellar mass black holes formed from the collapse of massive stars, to supermassive black holes, millions or even billions of times the mass of our Sun, lurking at the centers of galaxies. One such behemoth is TON 618, a supermassive black hole so gargantuan that its mass is equivalent to that of 66 billion suns. This cosmic monster resides over 18 billion light-years away, yet its gravitational influence extends across vast stretches of the cosmos. The existence of such massive black holes challenges our understanding of the universe's evolution. How did these behemoths form, and what role did they play in shaping the structure of the cosmos? These are questions that continue to drive astronomical research, pushing the boundaries of our knowledge. Black holes are not just cosmic oddities, they are fundamental components of the universe, shaping the evolution of galaxies and influencing the distribution of matter and energy across the cosmos. We've encountered neutron stars, those ultra-dense remnants of stellar explosions, and delved into the enigmatic depths of black holes, where gravity reigns supreme. But the universe holds other dangers, equally awe-inspiring and terrifying. Imagine a sudden burst of energy, so intense, so powerful, that it briefly outshines entire galaxies, a cosmic beacon visible across billions of light-years. This, my friends, is a gamma-ray burst, the most powerful explosion known to science. These bursts release an unimaginable amount of energy in the form of gamma rays, the most energetic form of light in the electromagnetic spectrum. To put it in perspective, a single gamma ray burst can release more energy in a few seconds than our Sun will emit in its entire 10 billion year lifespan. And the scariest part? They appear to strike randomly, emanating from distant galaxies billions of light years away. They are the cosmic snipers of the universe, capable of delivering a lethal dose of radiation across vast cosmic distances. The exact origins of gamma-ray bursts remained a mystery for decades after their discovery in the 1960s. Initially, some speculated that they might be signals from advanced alien civilizations. However, the scientific community has since converged on more natural, albeit equally awe-inspiring explanations. The leading theory is that these powerful bursts are the death throes of massive stars, collapsing under their own gravity to form black holes or neutron stars. These cataclysmic events, known as hypernovae, release immense amounts of energy, some of which is channeled into narrow beams of gamma rays. Another possible source is the collision of two neutron stars, those ultra-dense stellar remnants. These collisions are some of the most violent events in the universe, briefly creating a maelstrom of gravity, matter and energy that sends out ripples in space-time itself, known as gravitational waves. Regardless of their origin, one thing is clear. Gamma-ray bursts are a force to be reckoned with, capable of sterilizing entire solar systems from thousands of light-years away. The Earth fortunately resides in a relatively quiet corner of the Milky Way, far from any known gamma-ray burst sources. However, that doesn't mean we're entirely safe. In fact, some scientists believe that Earth may have been struck by a gamma-ray burst in the distant past. One such event, theorized to have occurred around 440 million years ago, may have triggered the Ordovician-Silurian extinction event, one of the most significant extinction events in Earth's history, wiping out a vast majority of marine species. While the evidence remains circumstantial, it serves as a stark reminder of the universe's potential for destruction, even from distant sources. Gamma-ray bursts are a sobering example of the powerful forces at play in the cosmos, forces that can both create and destroy on a scale that is difficult to fathom. But amidst the potential danger, there is also a sense of awe. These bursts offer us a glimpse into the most extreme environments in the universe, where the laws of physics are pushed to their limits. They remind us that the universe is a dynamic, ever-evolving place, full of wonder, beauty, and yes, even a touch of terror. We've journeyed through the cosmos, encountering remnants of collapsed stars and the gaping maws of black holes. But what if I told you these cosmic perils, as formidable as they are, pale in comparison to the true harbingers of chaos? What if I told you the deadliest places in the universe aren't single objects, but rather cosmic crossroads of destruction, galactic centers? Imagine a region of space where the fabric of space-time is stretched and squeezed like dough. At the heart of it all lies a supermassive black hole, a gravitational sinkhole billions of times heavier than our sun, greedily devouring anything that strays too close. But it doesn't stop there. These cosmic furnaces are also breeding grounds for stellar collisions, supernova explosions, and the birth of hypervelocity stars, all set against a backdrop of intense radiation and magnetic fields that would make even the most extreme environments on Earth seem tame. Now, picture a maelstrom of celestial objects, a chaotic ballet of stars, gas, and dust, all trapped in the gravitational grip of the central black hole. These aren't the serene spiral arms of our Milky Way, these are cosmic mosh pits where stars are packed together 1,000,000 times denser than our local neighborhood. Collisions are inevitable. Imagine two stars, each more massive than our sun, locked in a gravitational dance of death. As they spiral closer, tidal forces rip them apart, scattering stellar material like cosmic confetti. The energy released in these cataclysmic events can outshine entire galaxies for a brief but brilliant moment. And then there are the supernovae. When massive stars exhaust their nuclear fuel, they don't fade quietly. They go out with a bang, a spectacular explosion that can briefly outshine the combined light of billions of stars. In these cosmic demolition derbies, shockwaves ripple through space, triggering the formation of new stars and shaping the destiny of entire galaxies. It's easy to feel insignificant when contemplating such immense forces of nature. But amidst the chaos, there's a strange beauty. These cosmic crucibles, as deadly as they are, also play a vital role in the evolution of the universe. The death throes of stars, the violent mergers of black holes, the explosive birth of new stars, these events, while destructive on an individual scale, contribute to the grand cosmic cycle of creation and destruction. They forge the elements that make up our bodies, seed the universe with the building blocks of planets, and drive the evolution of galaxies over billions of years. So the next time you gaze up at the night sky, remember that the universe is not a static, unchanging backdrop. It's a dynamic, ever-evolving tapestry woven from threads of creation and destruction. And while the deadliest places in the universe may seem far removed from our little corner of the cosmos, they serve as a powerful reminder of the interconnectedness of all things. We've stared into the abyss, haven't we? Journeyed to the cosmic locations where the laws of physics themselves tremble, where gravity reigns supreme, and even light itself cannot escape the clutches of black holes. It's enough to make one feel rather insignificant. But here's the thing about perspective. It changes everything. From our vantage point, nestled within the safe haven of the Milky Way's suburbs, the cosmic horrors we've discussed seem a world away. And in a sense, they are. Take quasars, those ravenous black holes blazing with the light of a trillion suns. The nearest one is billions of light years away. The odds of us encountering one of those are about as likely as finding a penguin in a rainforest. And then there's Sagittarius A*, the supermassive black hole lurking at the heart of our own galaxy. It's a sleeping giant, thankfully. While it's certainly capable of unleashing unimaginable fury, for now, it's content to nibble on the occasional gas cloud, a cosmic cat more interested in a nap than a feast. Our solar system resides in a relatively peaceful neighborhood, a stellar cul-de-sac if you will. We're far from the galactic center, where the action is, and our sun isn't about to go supernova anytime soon. We're safe, at least for the next few billion years. So should we be losing sleep over gamma-ray bursts or being spaghettified by black holes? Not really. Our planet has weathered its share of cosmic storms over billions of years. We're still here, aren't we? A testament to life's resilience. But here's the catch. Just because we're safe for now doesn't mean we should ignore the universe's wilder side. On the contrary, these cosmic dangers offer invaluable lessons. By studying these extreme environments, we gain a deeper understanding of physics at its most fundamental level. We learn about the birth and death of stars, the evolution of galaxies, and the very nature of gravity itself. These discoveries may not have immediate practical applications, but they expand our knowledge, challenge our assumptions, and remind us of the vastness and wonder of the universe we inhabit. And sometimes, that's more than enough. The universe is vast, violent, and beautiful, a cosmic arena where creation and destruction engage in an eternal dance. We've explored its deadliest corners, peered into the hearts of black holes, and witnessed the awesome power of exploding stars. But most importantly, we've gained a newfound appreciation for the delicate balance that allows life to flourish on our pale blue dot. And the more we explore its darkest corners, the more we understand what makes our little corner so special. If this video sparked your curiosity, be sure to like, subscribe, and share it with someone who loves space as much as you do. What should we explore next? Wormholes, time travel, alien life? Tell us in the comments. Until next time, stay curious, stay safe, and keep looking up.